Sorry for the lack of recoil tech videos this week. I'm gonna have two next week. This week is just an update on my side project of building an analog ballistics calculator in Trailmakers. So, I still haven't figured out how to multiply two things, but last time I went in depth on how you don't need any like multiplication as long as you can model the issue smartly, which is what I've been doing. And so together, but I still need to be able to multiply stuff to convert different units. And to convert stuff into meters using the current unit which I'm using, I'm literally just measuring out a meter on a little roller bit and to see how many degrees it rolls. Um, and I got that output, but it's outputted as a variable. To turn it into a constant, I need to figure out exactly how many degrees it is. But the thing is, it isn't perfectly circular. It's closer to like a hexagon, I think. I don't know, I haven't measured exactly. So, to the nearest 5 degrees, it's about 235 degrees. But because I can't rotate, well, I guess I can rotate that far. But it's just easier for me to do it in like a smaller set of units. So I divided the whole thing by a constant of 5 by changing the speed from 0.05 to 0.01. And that gave me the about like 47 degrees about. And again, doing that in reverse, that gets me the unit of the speed that I'm working with on average, which I find that 0.2 is a pretty solid speed. So, well, no, I changed the units. Anyway, some unit conversions by changing the speed of the rotation to change how many degrees it rotates. I figured out it was about 235-ish degrees, as you should hopefully be seeing right now. It's not perfect. I'm going to do some math later to see if it lines up with how an actual circle would rotate along 1 meter, the circle's radius being a quarter of a meter, since a meter in Trailmakers is 4 of those studs. So I'm going to do the math for that to make sure it's not way off later. That's about all the like huge big progress. I guess you can't even really call it that big, but it's a start. Now I'm working on figuring out how I can model a parabola. Yes, I could probably try to solve for a parabola using like math stuff, but if I can figure out a way to model the ballistics, that would make it so much easier. I have a couple ideas, but they're all in testing. None of them are very practical. One step at a time. Going into the more basic things that I didn't go over last time, it's the mechanics of how it works. So, as you should hopefully be seeing right now, for basic addition and subtraction only calculator, there are a couple main parts. The thing behind, which you don't see, has the 2 servos stacked on top of each other, and then a free-floating thing which matches a stick which is being rotated by the servos to see how many degrees it has to rotate to line up. And that itself tells it how many degrees they've rotated in total. So when let's say the first one rotates 90 degrees, the next servo which is being added and subtracted also rotates 90 degrees. The output will be 180. And that's really it. That's the entire concept that I'm working off of. And it works, it's efficient. There is a small problem. It's that, of course, the sensors aren't exactly super precise. I can slow down the speed at which the servo rotates and tune in how tight the sensors are to the exact location to give a more precise output. But all that does is, in the end, it just makes me, then it can't react to operations fast enough. And if it does too many operations, like if it changes the position too quickly, it won't be able to keep up. And so it'll permanently desync. It'll never reline up again. And so you're going to have to respawn the creation. So, as a rule of thumb, keep the output speed the same as the input speed. And that usually works. However, even then, if you rotate both of them at once, let's say the first servo is rotating at a speed of 0.2. The next servo is also rotating at a 0.2 speed. If both of them rotate at the same time in the same direction, the speed is now 0.4. It adds together. Again, this is an addition and subtraction calculator. What this means is that now the output can no longer keep up. So when doing larger operations, sometimes it's nice to space it out, make sure it doesn't snap. Now again, you could just make the output speed match, like you could just set it to 0.4, but then that has problems where now it's even faster, and that means way more jittery and way less precise in the output. So it's a trade-off. Speed versus precision. That's how binary things work. I went over it in the last video. The thing with binary stuff is it's faster, it's more efficient, at the cost of reproducibility and precision. Sorry, at the very last bit there, I meant to say analog, not binary. But overall, it works. And it works really well. And it even works better than logic gates. As you should hopefully be seeing right now, the things that are in front, the servos that are stacked in front and to the right, are the ones operated by the OR gates on the bottom. The ones that are stacked back, those are still operated by the same system as behind. I feel like I should go into the display actually, because to understand what it's actually displaying, I feel like it'd be a good idea if I explained how to read the display. So obviously the degrees are the units, and I'm currently using it as a base 10 system, where the servos on top rotate 10 times, and the servo below it rotate once. And same thing with the middle servo and the bottom servo. So every 10 rotations of an upper one equals 1 rotation of the one below. So if you think of the top one as like the ones digits, like from 1 to 9, next one as like the tens digits. So like a 10 would be the top one in the 0 position, the bottom one in the 1 position, the middle one in the 1 position, and then the bottom one in the 0 position. That'd be 0, 1, 0. 0, 1, that's 10. And so on and so forth. I personally prefer a base 12 system where it's every 12 rotations, it goes to the next place over, because it's more like a clock and I'm used to that, but I set it to 10 so that it's easier for newer people to view that. And so the problem with logic gate systems is if you set it to rotate, and if you set the first server to rotate and the second server to rotate, you have the same problem of it desyncing, but now instead of having a small stopgap of where you can make it rotate fast for some time and the servo will still catch up, now it is capped by the speed of the output servo. If you adjust both values at the same time, they do not properly work together. And it can work with different speeds by adjusting the strength of the OR gates, but it doesn't work as well with multiple different speeds being added together. And that is something to keep in mind, because both those OR gates are plugged into the output thing, right? And the outputs, like when you have when you have two strong outputs of 1, full activation, to the output servo, it goes at an output of 1. It doesn't add them together. It just goes at an output of 1 because that's the maximum it can output, unlike my system, which has a stopgap, again, at the cost of precision and jitteriness. But my system is also faster because if you look closely, there's a 1 physics frame delay. Pretty sure there's like 60, I'm pretty sure it's like 60 logic updates per second. And there is that update, that frame of delay for the logic gates. I'm not sure if that's in my system. Pretty sure it isn't though. Future me here. So the reason why also you can't, so exponential functions. Theoretically, there is nothing stopping you with my system from taking the output and putting it into the input. And you can do that. There is nothing stopping you. The problem loops back to that limit on servo speed. If you send more inputs that say go full speed ahead, you have this trade-off of precision and speed, where sure you can do acceleration, but like values that like are exponentially growing. But the problem is it grows so fast because it's only limited by how fast the physics updates, right? Which means it it maxes out the speed of the servo very quickly, and the moment that it does, it's basically locked in to forever spin in a circle. It's not practically usable. Maybe if I set the acceleration really low. I keep saying acceleration instead of exponential because in this system it's literally showed as acceleration, where velocity is a changing, acceleration is the change in is like how fast it speeds up and changing the degrees. So it's there. Maybe if I change the acceleration to be super low and the top speed to be super high, it might be super imprecise, but it might give me an estimate of the acceleration. But like, is it worth it if it's so imprecise? And that's pretty much all I wanted to cover. And yeah, 2 videos next week. But yeah, that's it.